From the perspective of the mechanical part of the electronic jacquard machine, the main goal is to avoid the impact of excessively high lifting height during the operation of the electronic jacquard machine. Long-term continuous impact will shorten the service life of the mechanical part of the electronic jacquard machine. The main manifestations are: 1. Impact on module's box. Long-term continuous impact on the module's box will lead to a series of subsequent reactions. 1.1 Dynamic changes in proximity switch working distance. When it exceeds a certain range, the output signal of the proximity switch is abnormal, causing the electronic jacquard machine to receive incorrect instructions and generate incorrect actions. For example, a proximity switch with a working distance of 4 mm is usually selected, and the working distance of the static adjustment proximity switch is 2 mm, with a fault tolerance space of 2 mm. When the proximity switch working distance exceeds 4 mm, the proximity switch will momentarily not output a signal. When the proximity switch working distance is less than 0, it will damage the proximity switch and even cause damage to the proximity switch. 1.2 Damage to the fixed structure of the module's box or module's box. Persistent impacts will damage the module's box or its fixing mechanism. 1.3 Damaged modules. Persistent impacts can damage modules or cause them to operate in abnormal environments. Even fabric errors may occur. 1.4 Damage to vertical shaft or synchronous chain. The hard synchronization, vertical axis, or soft synchronization chain between electronic jacquard machines and loom can also cause damage due to continuous impact, even causing damage to the gearbox. Hard synchronization or chain, soft synchronization. 1.5 Damage to the loom motor, etc. A large and long-lasting impact may damage loom motor, such as locked rotor of motor. Just like a domino, it causes the system to crash. The mechanical life of the electronic jacquard machine is greatly shortened. For example, a brand new jacquard machine initially works normally, but after a period of time, its working condition deteriorates sharply, requiring more maintenance costs, and it is even better to purchase a new jacquard machine. 2. Deformation of the lifting knife. The deformation of the lifting knife can be divided into static and dynamic. 2.1 Static deformation, that is to say, irreversible deformation, can be measured during loom stop. 2.2 Dynamic deformation. Dynamic deformation refers to recoverable deformation, which occurs during working and is restored during stop. Measurement is difficult and can only be indirectly reflected through mechanical fluctuation of real-time online detection data. Electronic jacquard machines usually require adjusting the height of the lifting knife in the following stages. A. Upon arrival at the weaving factory for installation and commissioning. B. When there is a problem with the jacquard machine and the jacquard machine is repaired. C. During regular maintenance of electronic jacquard machines, etc. Usually, professional tooling, professional tools, is used to statically adjust the lifting height of the knife. See other videos for details. Evaluate whether there are impacts, and quantify them by interpreting mechanical fluctuations in real-time online detection data. See other videos for details. It is recommended to use free tool software for big data analysis of the real-time online detection data of this electronic Jacquard machine. Understand how this electronic Jacquard machine evolves from quantitative to qualitative changes, and regularly replace vulnerable parts such as lifting knives and chains, etc. We will provide free technical support. Please send me all the real-time online detection data of this Jacquard machine. It's best to send me real-time online historical detection data in bulk through free tool software. I will interpret these real-time online detection data, propose suggestions and work with engineers to solve the current problem with this Jacquard machine. In the process of solving problems, we also learn from engineers. Thank you for watching this video. Goodbye.